Thank you. Thank you. Thank you, everyone, for joining. I'm April Edwards, and this is Henk Boelman, and we're going to talk about AI.
Yes. Hello, everyone.
So I'm April Edwards. This is me in AI when I had long hair. I'm a Wonder Woman fan, so biased, that's my favorite photo. But I'm a senior developer advocate at GitHub. I talk about the cloud. Is your sound cutting out? I talk about the cloud quite a bit. I talk about developer experience, and I was previously at Microsoft, so I've been at GitHub for about 7 months now. And I spend a lot of my time talking about to you guys in the community about developer technologies, writing code. I have about 24 years of experience in tech. I've worked in development, I've worked in operations, melded them together and kind of got DevOps out of that. So I'm really excited to be back here in Portugal. I haven't been here in a long time. And I'm joined by my colleague, Henk Boelman.
Hello, everyone. So my name is Henk Boelman, and if you give my image to AI, this comes out. I'm a senior cloud advocate at Microsoft. I work at Microsoft for about 4 years now, talking about AI before all these cool things you could do with these images and so on. And before that, I was a developer building software for, I think, 15, 20 years in the .NET ecosystem, using Umbraco a lot. So today, our story starts in the year 1955. 5 years after Alan Turing developed kind of the Turing test, a test to test the intelligence in machine. And the challenge there was that the human should be unable to distinguish if it was interacting with a machine or with a human. But what makes 1955 so special? 1955 was the year that John McCartney for the first time coined the term artificial intelligence. So almost 70 years ago, people were already thinking about this concept. And this concept was launched at the famous Dartmouth conference in the summer of '56. And there, AI was defined. It is the science and engineering of making intelligent machines. And the first 10 years after, not much really happened, except kind of this kind of happened, because of course the movies got, and the movie industry got like away with creating cool looking intelligent machines. So that was perceived back then as an intelligent machine. So let's forward to the 60s. And in the 60s, the real intelligent machine came along, named Shaky, the world's first mobile robot. Isn't it beautiful? So it was developed in '66 to '72 by the Stanford Research Institute. And Shaky is kind of the real great-grandfather of all the self-driving cars. Because it was kind of limited, the hardware. But what was really special about Shaky is that this was kind of the first time where hardware, software, and all kind of different components of software came together in one single machine, making kind of the robot understand the surroundings.
So enter in the 80s, my favorite decade. Why? We had the best movies, music, and cartoons, like The Simpsons, Back to the Future, Indiana Jones, and the Raiders of the Lost Ark, all great stuff. So this is really, when we then entered into the 90s, we then had the field of machine learning. This is where this was born. Now, this is where more data and the internet really became available. We had some cool technology advances in that time, but really that interconnectivity of the internet brought forward those technologies to us. We started seeing booms in all the computer industries, the rise of IBM, Apple, Microsoft even, the people that pay our, pay our bills. These all rose up in the 90s, and that connectivity provided those advances that we could leverage and take forward to develop AI and machine learning.
Cool. So what we wanted to illustrate here is that AI has come a long way to where we are now, the age of generative AI. So in the 50s, the field was kind of defined. In the end of the 90s, machine learning became a thing where we were starting to develop algorithms to improve upon existing data, and that those algorithms could learn from data instead of like the if-then-else systems. Then deep learning became available, and now in 2021, we have generative AI as a field and available to all of us. So we're all here to listen about AI. So I'm wondering who haven't been playing with OpenAI. That's what I thought, like no hands at all. Super cool. So in the old days,
In the old days, like 10 years ago, 5 years ago.
yeah, no,
Back in the day?
I would say 3 years ago.
Okay, back in the day, 3 years ago.
Exactly. We were developing models the traditional way. And with that, I mean, we would kind of have a data set, a very specific data set for a very specific problem. We would train a model, and we would then deploy that model, manage it in production, and kind of offer it as a service and integrate it. But if you look at this picture, you see a lot of DevOps pipelines, right?
How many of you have production models that recently went out of service in Azure because we've replaced it with new AI? Okay, I'm the only person that, okay. I actually had a production system that we built. We built sentiment analysis, we trained the models, we did all the things in a production level environment for a customer, translating data, and it is now going out of service because the new generative AI has taken over this. So all that work and time, toil, and 6 months of project work that I cried over is now useless because we've moved on.
And actually, that is indeed replaced by foundation models. So the future of these models, or what we are building now, actually, the future is now, is that these models are flexible, usable, and you can kind of adapt it to your problem space. So these models are trained on a massive amount of unstructured data. Being trained, I will tell you later how long that takes for them to train, and then you can adapt those models to a very specific task. So basically, you have one big model now to kind of rule them all. And talking about the size of these models, we had like some models that we thought were big, but then OpenAI came along, and I'm actually now talking about GPT-3, not even 4 or the new ones that have been released. So this GPT-3 model has around 175 billion parameters. And then you're thinking, parameters, 175 billion, how much is that? So an average brain should have around 60 trillion parameters. So still 300 times more parameters than the GPT-3. It took around 9 days to train it. Not that long, kind of what you think, but it used a lot of Tesla V100 GPUs, but the cost for those 9 days was 4.6 million euros. So it used a lot of GPUs. And I don't think you want to be the one that makes a mistake in like the safe method in the end of those 9 days. I don't think you want to be that person. So this is kind of putting it in perspective how big it is. So if you're lucky enough to have a gaming machine with an RTX 8000, I don't have one, I have a 3000 still, so a 8000. It will still take you 665 years to train a GPT model.
I won't be alive then, I hope.
No, and your computer also, there must be a power outage once. So that is how big these models are and why you need like a cloud or a data center to train these models. So let's start with how we can interact with these new models. So we were always used to interact with these models by sending an image in like an array with data. With these new models, we can kind of send natural language. We can talk to them in English. It even works in Dutch, so that is all super cool. So we do that through a process that is called prompt engineering. And prompt engineering is a concept in natural language processing that involves embedding descriptions of tasks in input to prompt a model to output the desired result. In other words, we prompt typically a problem description to the model, and then we instruct it how to solve it, and it will kind of respond back to us with some solutions. So to make it a little bit more clear, there are a few ways of prompting. We have kind of the most easy prompt, write a tagline for a trip to planet Noura. And this kind of also illustrates another problem, because Noura is a very fake planet. but it will describe for me, it will create for me that tagline, saying, discover the wonders of planet Noura, a journey of cosmic exploration awaits. So it kind of completes that. Another thing where April is going to show more, it can help you with code. You can describe your SQL table. These are my fields. This is how the relation works in natural language. And then ask to create a SQL query. And it will return to you an SQL query. Or you can ask Bing, like, create a photo for me for a planet Noura from space, and it will generate a perfect image of a planet in space. So with the latest models, so we had models Jet 3.0 and the older models, you had a single prompt. But with these newer models, you have a system prompt. And that system prompt you can use to kind of guide your model on how to react. So if I would put in my system prompt, you're an AI assistant that helps people find information and responds in a rhyme. If the user asks you a question you don't know the answer to, please say no and don't make anything up. So if I would prompt it with a question, what can you tell me about John Doe? It is going to tell me, dear John, I'm sorry to say, but I don't have any info on you today. So you see, it is not giving me information, making up information about the person, but it is still responding to me in a fun rhyme with just like one line in the system prompt. So we can take that a little bit further. So the meta prompt or system prompt, they're the same thing, go by different names, of course. So I always start with grounding my response, kind of tell the model not to make up any things. So if I give it extra information or anything, it should keep it in that direction. Then I specify the tone. Your responses should always be polite, positive, interesting, entertaining, and you must refuse to engage in argumentative discussions. Because can you imagine you have a nice OpenAI-powered chatbot on your kind of website, and someone is not happy with the product, and they are unpolite, so GPT-4 probably will mimic what the input is. So if you are unpolite, the chatbot is going to be unpolite. So you want to have that line there, because you don't want your website calling people any names. That will not be good. Then let's put some safety measures in there. Like kind of, if the user requests jokes that can hurt a group of people, please do not do that. So just decline to do so. And in the final thing, jailbreaking, which is always kind of a fun concept, because you can ask the model the rules. So it will tell you exactly what someone has written in the system prompt. And then you can use the prompt to overrule the system prompt. So, but if you put in the system prompt that the system prompt cannot be overruled, it will not overrule it. So always take some measures in that. Another cool thing you can do with these models now is that sometimes you have unstructured input, but basically what you want to do is get data out of that input. So if I, in this case, have a hotel search engine, as a chatbot, people will ask a hotel with a private beach costing 300 euros in a fake city. I do not want to search all on that. I can find hotels with a maximum of 300 euros with a beach, with a private beach, very easily with an existing search engine, with Azure Cognitive Search or anything. So with Azure Functions, or with Azure OpenAI function calling, that's the correct phrase, I can specify a function. And what it will do is, because I describe kind of here what needs to go in a variable locations, it will extract that out at unstructured data and put that in JSON for me and returns that JSON. So this is super easy to use when you're building kind of a RAG application or a bigger application where you need to kind of extract things from your current context. So another thing that is very important to realize with these models is that you have a context window. So your conversation can only be as long as the context from the model can kind of handle. So GPT, okay. So GPT-3 has 3.5 is like 4,000 tokens input, while GPT-4 can go up to 32,000 tokens of input, which kind of depends on your use case. So the conversation at a certain point will stop, and the top will fall off of that conversation. So if April stopped coughing, I will hand it over and you will show how you can actually use one of these models.
All right, I apologize. I'm choking on air. We're going to write some code, and I'm going to try and talk through this and not choke. We have some Python code here. How many Python developers do I have? Anyone? Good. I hate Python too. Oh, you had a couple. Okay. Python's not my strength, but I've inherited this net new project. Oh, hold on. So I'm actually running this from a GitHub Codespace on Henk's machine. I can run this from my machine, any one of your machines. The reason why I'm using a GitHub Codespace is because I'm getting the VS Code experience in the cloud. And if my machine goes down, I can use his, or vice versa. So we have some Python code here. We've just inherited this project. And when I look at this code, when I look at this code, I probably have used Copilot in the past. How many of you used Copilot in the past to do some code? All right, a few of you. So traditional Copilot model, we start typing, and it will generate some code for us. Now we are waiting on the internet. There we go. And I might accept this code. Now the problem with doing this is I don't always know the context, right? Why did it generate this for me? I want to ask it questions. Maybe it's not the right code, but Copilot's pretty cool. It does help me write a few lines of code, but we kind of have a new experience that I want to go into, and it's a little bit more around the prompt engineering side. So I want to go ahead and use GitHub Copilot Chat. Has anyone used GitHub Copilot Chat yet? A few of you, awesome. So I use this almost in my everyday life, just to help me with new projects. When I inherit a new project, getting started is always the hardest barrier. What is the code doing? Someone else wrote this code. Now, I know that I've written code before, and I'm like, why did I write that? What was I thinking that day? So when I'm inheriting a project, I often use GitHub Copilot Chat to literally explain the code. So we have some regular expressions here, and I'm going to ask GitHub Copilot to explain the selected code for us. So it's told us what these regular expressions are doing. So it says the first regular expression is used to validate some email addresses. We can see that the second one is validating some phone numbers, and the third one is validating some strong passwords. Now, that's okay, but for me, this isn't very readable, so I'm going to ask it to make the code more readable. So it does. It actually gives us some prompts here to make this code more readable. It gives us some output. I'm not sure I like what it's done. I think we can do a little better. I'm going to have it separate out. I don't like the way it separated that out, so I'm going to say separate out, the validation functions and the comments it's added for us, and see what it gives us. Nothing. Awesome. No, that was not helpful. No, that was not helpful. Sometimes you can't get good help these days in AI, can you? So let me go ahead and get this expression highlighted again, see if we can get a better response. Let's see if it gives us a different output. So the problem with Copilot is it's taking our context. So it's giving us actually pretty much a pretty similar output to what we had the first time. But that's actually not what we want. So let's see if it'll separate out the functions for us again in a better way. No. We've broken Copilot today. So sometimes with prompt engineering, when we're doing things live and on stage, our demos don't go right. We're doing this live and on the fly. It really hasn't given us what we wanted today. But traditionally, it would give me a better output. I'd bring that code over. And actually, the output it's given me is probably a little bit cleaner than I have today. So I can just go ahead and bring that code over. It's not perfect, but we can work from that. But it's taken out my expressions. It's separated them out. It is a little bit easier to read. It's not really identical to it's not actually what I was looking for, but it's a good starting point. But maybe I'll see if I can add commands or add comments to this code. I really like using GitHub Copilot Chat to add comments to my code because we're terrible at documentation. Okay, it's gone back to that again. All right, we've broken it. So we're going to move on. So here's another use case for GitHub Copilot Chat. Now, while we didn't fix that code, I know in this line of code, I've got bugs. I always like to tell people that I like coding in dark mode because the light mode attracts all the bugs, which is true today. But I know that I have some code here that has bugs in it. Now, there's a couple things I can do. I can hit slash. I can ask it to simplify my code, write some tests from here, but I'm just going to ask it to propose a fix for the bugs in my code, very bluntly. Thank you. So it's made some changes for me. I don't really feel like it's actually made some valid changes, but let's, YOLO, let's run our code and see what happens. It did. It fixed our bugs. So we get the output that gives us a valid output. It's fixed some code for us, so I'm glad one of my demos actually worked today. The other thing is, now that I've fixed my bugs, I want it to make some unit tests for me. So I can just ask it /tests. Generate some unit code for the current test. So we don't make this mistake again. So I did try to explain some code and clear out some code. I managed to fail at that. But then I've asked it to fix the bug. It's fixed the bug for me. And actually, it's giving us some unit tests. Because what's really important is to have code coverage with our code. How many of you have 100% code coverage? We can chat after. I don't. I'd love to have it. But this has actually helped me get a starting point with some of my unit tests, generate more unit tests, and pull that code over. So I can very easily just pull my code over and create a new unit test file, insert that into a new file, and we have some unit tests, and we're good to go. So we can run our unit tests on our code. Now, the other thing that's really good is, again, I said I don't really love Python. It's not my favorite language, but maybe I'm learning Python, and I want to know how does variable visibility work in Python. The other thing I really like about Copilot is even though I asked it to give me some comments, it didn't, but it's explaining to me what variable visibility is, and it's going to spit out some examples for me. So I have an explanation and that visual. For me, I'm a visual learner, which is really helpful, and I know why it's given me that. So I can go ahead and learn about topics. I don't have to leave the context of where I'm writing my code, so that's been really beneficial. But when we talk about responsible AI, this can only respond in the context of our code. There's a lot of questions around security of code when it sits with GitHub Copilot, how it works. GitHub Copilot has guardrails in place. So I'm going to ask GitHub Copilot, who is your favorite, not that I can spell, favorite speaker in this talk? It does not have preferences or emotions. Now, this is a really valid point. Now, as we train the models, we have to put guardrails on, but it's not a sentient being. So it can fix my code, it can see the context, but it's not going to actually tell me anything else that I want to know. If I ask it, should I have a cup of coffee? It'll give me some advice, but it's not there to be that. It can't tell me that I'm more awesomer than Henk, or Henk's more awesomer than me, and awesomer isn't a word, I know. But it has those guardrails in place to do that. So there are some boundaries in there for a reason. Can we go back to the slides, please? So we did this in a little bit of reverse order. So when we built GitHub Copilot, it has been the most highly adopted AI tool around the globe thus far. And the reason why we built it is for the sake of developer happiness. And you go, well, okay, what does that matter? Well, if you're happier as a developer, you're going to write code faster, you're going to do more important tasks in your day-to-day job, and you're going to stay at your organization. How many of you have ever left a job because you loved your manager? No one. All right. How many of you left a job because you were bored? Because when I do those menial tasks, I get bored and I get fidgety and I go do things I probably shouldn't be doing. So we've run some numbers, we've pulled some data, and we found that 75% of developers are more fulfilled in their jobs. We're taking away those menial tasks. If I have to go spend an hour finding documentation on code, why my colleague Henk wrote that code, Henk didn't write that code, but let's say Henk wrote that code. Why did he write it? Why did he do it that way? I have to go chase that down. That's not fun. Writing documentations, or maybe those repetitive tasks that I want to automate, I can do with Copilot. I can go write the more fun code. But more importantly, I can be more creative when I write code, which is really important. It's also been really helpful for helping people learn languages. So we just did a little bit with Python. We had it explain some code to us and add some comments to help us move forward with how we do these things. We have some other really good stats. We find that 96% of people have faster code completion. I can tell you that if I was picking up that code net new and doing it on my own, it would be a train wreck, and I wouldn't have done it that quickly. What we do with a lot of customers is we say, right, let's test how impactful this is to you. So we'll sit down and pick a task out of our sprint and say, right, developer A is going to complete this task, and let's say it takes them 5 hours or 4 hours. Then we have them complete that task with GitHub Copilot, and it takes them 5-10 minutes or 2 minutes, and they've been able to complete that task. So we've been comparing those times, because as a developer, you want to be able to just write code and be productive. So how do we use these models to help us do that? And more importantly, being more in the flow. I was a little disrupted with my comments and my coughing and all that other good stuff, but I want to be able to sit down in the limited time I have every day and write better code. We also know that we have faster project delivery, and I think in a world where, unfortunately, in the tech industry, we're being pressed to deliver more with less. So how do we be more effective as a human? And we're living in the era of AI. So, at Microsoft and GitHub, we love statistics. We love knowing how things work and how they work and how they impact us. Because we can talk about all this AI modeling, and this is great stuff. But how do we show our impact as individuals? I'm not being measured by lines of code. I'm not being measured by how many hours it takes me to do something. How am I able to deliver something to my organization to provide value? And that very often is very much some of these metrics that we can live off of. So here's our little marketing slide about GitHub Copilot. We have GitHub Universe coming up in a few weeks. It's going to underpin everything we do in the developer experience. The reason why we've done that is to make you, again, a happier developer. It's underpinning how you're going to write pull requests and do all these other things. So I showed chat a little bit. There are things I apologize I'm not allowed to show yet. Okay? Just not allowed because this is being recorded live. We have to be careful of what we show. But we want to improve the context in which you write your code and the code quality. So we have things like GitHub Copilot chat that I showed off a little bit. But we want to be able to take command of what we're doing in the CLI. When I first started off in tech, everything was command line. And then we went to GUI-based. Now we're back into the command line again. But when we're switching that context out of the command line, and then we're going somewhere else to find our answers, are they valid? How do we measure that validity? And we have to switch that context. So being able to go into the CLI, type in what you need, and maybe look up commands for Git. I mean, I have merge bombs all the time. How do I undo a merge bomb? It can tell me in that CLI, or what specifically is wrong with my Git push. So we're adding collaboration. When I am trying to get a task done in my day-to-day job, I am rushing to get that pull request over the line every single time. Why? Because someone's waiting for me to finish my job, and then it looks better that I've delivered something, but I rush that pull request. And then sometimes when someone's picking up that pull request, they're going, all right, what is the context of this pull request? What's going on? I got to go read the code. With GitHub Copilot chat, GitHub Copilot in pull requests, it's going to help you fill out your pull requests. It's also going to look at your code and go, hey, you could actually put in some unit tests. So for Mr. 100% code coverage, awesome. For the rest of us, it will help us tell us where we may have missed those unit tests, and we need to fill that gap. It'll help us add all those things in. The other thing is documentation. Who loves writing documentation? I got one hand. There's always one. Yes. Yeah. I don't love writing documentation. So this capability is coming to be able to write documentation effortlessly. I have been testing this out. I can go through all the GitHub docs. How do I do a thing? What is a pull request? What is Git, etc.? How do I use this product at GitHub? I can use that documentation in the GitHub docs. So if you go to docs.github.com, it is searching that and giving me that answer in my browser experience. So I'm not have to go off and Google or Bing the answers. This is coming to Azure as well. So what Hank's going to show shortly is going to be in Azure. This feature is coming to Azure. The next phase of this, we want you to be able to search your own documentation more effortlessly. I don't know one organization that doesn't have legacy docs and tech debt in their teams, right? We all have it. We've all built it up. How do we get through that? By adding in this capability to search your documentation. So we call this the 10x developer. What does this mean? Being able to do 10 hours worth of work in 1 hour, right? 1 hour's worth of work in less time. Be more productive. Now, I kind of hate this phrase, the 10x developer, and be more effective, but the reality is I don't get to write a lot of code as much as I want to these days because I have so many meetings. I have so many other tasks sitting over top of me, and I'm waiting on other people to do my job. So in that time we have, how can we be more effective and more impactful? Now, this stuff's all great, but custom models. Let's talk a little bit about custom models and what's happening. So it's great we have GitHub Copilot chat, but if you're working for an organization that has very specific requirements, this may not fit your requirement or your specific needs. So we have custom modeling coming soon. When I say soon, it will be presented at GitHub Universe of the new capabilities of it, how you can build it, how GitHub builds the custom models, and we're going to talk a bit about how Microsoft is building the custom models for Office. So all this capability is going to come to you as a consumer, so that you can build the custom models that are going to be right for you. We do have an article out of how we built our LLM applications at GitHub. You can scan the code and get to it, have a look at it. All this new stuff is going to be released in a few weeks, so there's a lot less that I can talk about that I'd like to, but it is coming. You'll have access to the data to see how you can train your models, and we have some blogs for you all to see how you can train your models as well. And I think we're going to build some code from here, and I think Henk's going to do some cool stuff.
Exactly. Cool. Before we're going to build some code, or our own large language application, let's talk a little bit how these models work underwater. And yes, this one is also generated with Bing. So how do large language models work? So what we have is we have an input in natural language. It goes through a tokenizer. Then those tokens are being sent to the model. The model returns a probability index of most likely tokens, and then it will return natural language as a result. So if we zoom into the model a little bit, how does that work underwater? So these models take n tokens in and produce 1 token out. And that would be super helpful information if you would know what a token is. So a token, it is not a word, it is not a letter, it is, in case of OpenAI, it is a short sequence of letters that sometimes is a word like we need to stop, kind of. But if you look at a word like anthropomorphizing, it is chopped up in 3 tokens because this word is kind of long and not very much used. So if we have a sentence like this, it is 43 characters and 11 tokens. So the model takes tokens in. So 1 token in, n tokens in, a lot of tokens in, and it produces 1 token out. But we all have seen that it generates a lot of tokens out. It is a sentence, a paragraph, even some Word documents. So how does that work? So actually, what it is returning is being applied in an expanding window pattern. So you give it a token in, you give it tokens in, it produces a token out, takes that input again, produces the next token out, and so on, until it reaches a certain stopping condition. So the next thing you might wonder is it going to produce the same token every time? And the answer is no. So I was actually lying when I said it produces 1 token out. It actually returns a probability index of most likely tokens. So it scores those tokens and it will return like this index. And there are 2 parameters that can influence the token that is being picked from that probability distribution. So we have temperature that influence the creativity and randomness of the token that is being picked, and we have the p-top value that is influencing the deterministic and the more focusedness of the token that is being returned. So with these 2, you can influence how random the token is picked from that probability distribution, but it will not return, it is not likely to return the same token twice. So now we know a little bit how it works. So basically OpenAI, the model, the only thing it does is predicting the next likely token. So we want most likely to build something based on our own data because the model's knowledge is kind of fixed at the moment of training. So that is mostly with GPT-4 and 3, it's around 2001 and 2022. So the knowledge is fixed. But it doesn't have, most likely, the knowledge of your company. Let's say you're building a server support system, or you want to search your own internal database, insurance information. You can name so many use cases here, but the model doesn't have that knowledge. And the system prompt is like short. You have 32,000 tokens, so you can't just put all the information you have in there. So what we mostly say is use a vector database, create a vector database with all your information in it, look up some relevant snippets with vector search, inject it into the system prompt, and then use the model to reason over that. So that sounds like a lot of work, right? Building a vector database, chunking up your documents, creating vectors, and so on. And you might not even know what vectors are and how to use them and how to chunk your models. So luckily, we have Azure OpenAI service on your own data. And that will kind of help you kickstart these type of projects. So you bring your own data, and that can be from a lot of data sources. It can be from a blob storage, from your own hard disk, connect to your SQL sources, third-party applications. We have our Azure OpenAI service that is OpenAI, but then deployed in Azure so that it is safely in your Azure subscription, so it can connect securely to the data, and we promise you that we will not train the models on the data you are giving it in this solution. So we can use now these models to kind of go over our own data, and we have an app or Copilot there. So you can see this kind of as your own Copilot builder on your own data. So let me show you how that works. And let's build one of these Copilots in a few minutes. So if we can switch to the laptop. Yes, perfect. So here we have our Azure OpenAI playground. So if you create an Azure OpenAI resource in Azure, you will have this to play with. So we have the system message on the left, where you can put the input on how the model has to behave. We have a chat session where we can kind of make a conversation with our model. And then on the right, we have our deployment. We can pick the model we want. And here we have the parameters, kind of what I explained, how to control the response of the model. So we click that away because we don't need that. And we have a tab here, add your own data. So what we can do is we can add our own data. So I'm selecting upload my files, store it on a blob storage called OpenAI My Own Data. That is my blob storage in my subscription, secured by my Azure OpenAI, Azure AD. I'm selecting a cognitive search resource. So you will need Azure Cognitive Search in your subscription here, which is 2 times clicking, or you can just follow this link here and it will create it for you. I haven't customized Azure Cognitive Search at all for this demo. We call it the index NDC Porto. We will add vector search, select an embedding model. I'll explain later what that does. Click next. I will browse for my data. You can see it are markdown files. I will show you the content of the markdown files later while it is creating my index. Click upload files. It's now uploading it to my blob storage. Files are uploaded. Click next. I configure the kind of search type I want to use. I also dive into later what these things already are. So we're going to use hybrid search together with semantic search. And I click save. It is now going to index my files, create a vector index for me in Azure Cognitive Search underwater. So what was in the documents? In the documents is product information, because I am a retail store in this demo that sells tents and shoes and all kind of outdoor materials. We have the name, we have pricing, we have technical specifications, we have how to set it up.
Can we have Inception?
How?
Can we use chat to write the data to then upload to your model?
Of course, that is how we generated the data for this demo. We wrote a lot of customer reviews for that, some warranty information and contact information, and we combined that in some readable documents. And we've done that for a few products. So indexing has not started. It has processed the files, so that is a good sign. Okay, so the indexing has started. So when this indexing is done, you can click deploy, and it can deploy this as a website for you that is automatically protected by your Azure Active Directory, so it is not open for the whole world to use these models. So now we see here, we have our uploaded files, we have our index, we can do some advanced settings here, but now we can chat over our own data. So we will greet the model, we say hello, and we ask now, can you recommend a tent for a hiking trip? And now it is using kind of Azure Cognitive Search in combination with the model, and it is not doing that now, so we will ask it again. Cool. So now you always have to ask twice. It is generating some recommendations based on my question. It is saying, based on the provided documentation, the Skyview tent and the Alpine tent are the ones that are very useful. And I found that in these documents for you. So it kind of references also where it is found. So the response is kind of grounded to those documents. And if I start asking it about the weather and so on, it will refuse to do that. So if you deploy the website, it takes around 10 minutes to deploy, you get this kind of interface where you can also ask, can you recommend me some hiking shoes, and summarize the 3 pros and 3 cons of these shoes. And then it will return to you like, sure, based on the information from the documents, here are some pros and here are some cons. So with a few clicks, you can see how it works on your own data. And a cool thing now is that you can look at the index that is generated for you and learn how it has chunked and indexed this data. So you can find all the documents here. Like, here's all the content, here are the content factors, what it has done. So this is out of the box and super cool to show like a POC for your company. A few documents with your documentation, Word documents, it doesn't matter. It all works. So let's go back to the slides and talk a little bit how this works under the hood. So these applications are called RAG applications, Retrieval Augmented Generation applications. So that is a pattern we're seeing very successful for a lot of companies that ask, hey, I want to apply OpenAI models, but I want to have it only reason over my data. So the idea of a RAG application is that you have your knowledge database somewhere, and you have your large language models separated from each other, and you have an orchestrator in between that kind of mediates between these two components, and then you have a front-end application that talks to that mediator to show the results. So there are a few ways of doing that. You can build like kind of plugins for other systems to kind of extend it with your knowledge, or you can build it from scratch. But the key element that you need to remember from these applications is that it allows you to bring in new data without retraining your model, and you use the model's capabilities to absorb kind of that new information, reason about that information, and give answers. But you don't use the knowledge the model has about facts and products. So if we dive into those kind of retrievers, those retrievers can be basically anything, but what they need to do is You need to find the most relevant snippets in a large data collection, kind of that match your search query. I was asking for tents. So you want to find those most relevant data and have those snippets with the information that you need about the products, for instance. But you want to use an unstructured input as a query. And we have a lot of systems that are already doing that. You're doing that, I think, every 15 minutes, you're using one of them. And they're called search engines. They're super good in looking up information. And we already have that in Azure Cognitive in Azure, we have Azure Cognitive Search. That is already there into the whole, into your whole Azure enterprise environment. So your data is secured, security is handled, and it can connect basically to every other resource to index them. So the new thing we've launched is that it has the ability to now search with vectors, to do vector search. So before we dive into what vector search is and how that all works, let's first define kind of what vector search is, define semantic similarity. So the concept with vector search involves training a model in a high-dimensional vector space in such a way that words and phrases that mean the same thing are positioned close together. And when someone told me that, I was like, yeah, sure, you with your semantic kind of space. So what it for me, when someone explained it to me, when I understood it was like, if I would have a search engine that will search for hotels, and one hotel description is this hotel is located at the ocean, and another description is this hotel is located at the beach. Those two in a traditional keyword search, it would just show me, if I would search for ocean, an hotel with ocean and not with a beach. But because you have trained that model and these things are very close in the semantic space, it will both return hotels on the beach and hotels on the ocean. So an OpenAI takes all that pain away, so for positioning those or creating those vectors for you, because there is a text ADA 002 model to create those kind of vectors, those embeddings for you. So if you want to use that in a search application, you first need to kind of vectorize your documents. So that is on the top here. We create embeddings, and vectors are exactly the same thing, by the way. So we create embeddings from our documents. That can be pieces of text, but it can also be images, audio. You can create vectors from those ones. So you create these embeddings and put them in an index. Then, if the query comes in, you vectorize that query too, create an embedding from the query, give it to vector search, it will do the magic, and it will give you the search results that are closest to that vector. So then, when you have those search results, you can kind of put the snippets that you have, the relevant information, into your system prompt. So I have looked up the shoes, in this case, that fit my query. I put them into the system prompt, into the meta prompt, and now I can ask, I need warm waterproof shoes to go on a hike. It has looked up those relevant documents, put that in the system prompt, and then it can answer me. Like, sure, I'm happy to help, and these are the products that are relevant for you. And it will reason about it. So if you ask, give me the pros and cons, it will kind of summarize that for you. So that was a lot of talking. We're all developers, so let me show you how this works in code.
I'm gonna come watch.
You're going to watch me do Python?
Yes, and type.
Cool.
Nothing like pressure, right?
Oh, no, nothing like pressure. So first, yes, we have the code here. So I want to start with showing vector search from just raw HTTP posts. So what we are first going to do is we're going to create an index with a field in Azure Cognitive Search with the fields ID, text, category, and vector1. And this is my vector configuration. I'm stating here the dimensions of the vector. We're not going to have like a huge vector like 1536 like OpenAI has. We're just going to use 3 dimensions for the vector. And we use my configuration with that says the algorithm here. So I'm going to do send, and bam, the index is created. I'm closing that, and now I'm going to add 3 documents to the index. So the action is upload these documents. The text is here. It is a category A, and here is the vector. So the vector is 1, 2, 3, 3, 2, 1, 1, 2, 2. So I'm going to upload these documents, and I can see them actually back here. If I go to my indexes, we have the vector index we have created, search, and I'm seeing my documents here. So now I can kind of search. I can do pure vector search in this case. I'm just searching in the field vector1 for this vector, and it will return me kind of the closest vector, which is the first document in this case. But the cool thing is, in Azure Cognitive Search, we can combine a lot of things because we already had a lot of search capabilities built in, like filtering on categories, because that is super easy. So I can add a filter here, so I'm still searching for a vector, but in combination with a filter. I'm searching, and now it will return only results with category B, and then this is the closest one based on the closest vector. And then to make it even better, we can search for keywords in combination with vector search, which we call hybrid search, which makes it super cool and super effective for these kind of RAG applications. So the second document is here, this is the closest vector, and this is the score. So I hope this kind of illustrates how vector search works and how you can get the most relevant document out. So in the next demo, I'm going to show you how to put this into a prompt. So now we're going to just build the experience we saw Azure add your own data doing, but then from scratch in a Jupyter notebook, because we all love Python, right? So we start with importing our dependencies, and we're just going to upload the data to, or we're going to index the data in this array. And while we're doing that, we're going to create the vectors here. We give it the content. This is basically the whole content from the Markdown document, and using this model. And this get embedding method comes from the OpenAI package, so I don't have to write anything. The only thing I have to do is call this method, give it the content and the model I want to use. Then adding it to this array, and here we see it has indexed all my documents. I'm going to create an index in Azure Cognitive Search called products with an ID, the content in plain English, or the file path where it is found, the data, so I can reference to the documents, and then a content vector that we have made with the method above. So here, my vectors are 1536 dimensions. I'm creating the index and uploading my documents, and it has done it already in 3.6 seconds. And now we can search the index. So my query here is, I would need, let's run it, I need warm waterproof shoes to go on a hike. Can you give me a few recommendations? And look in the index products. So here, doing a simple search, connected to the search client, building my input vector, then searching that, and returning the results. So it has found 3 documents that are relevant. So what I'm now doing is I'm going to construct my prompt. So I'm starting down here with get answers from OpenAI. This is my query. It is a little bit longer. It is, I need a warm waterproof shoes to go on a hike. Can you give me a few recommendations, summarize the pros and cons, and the user reviews for each product? So that is my question to the OpenAI thing. So that comes in here. So it quickly does a search query. It loads the most relevant documents, like we've seen above, and it has put the content, the documents, in this string here. It's saying the catalog, the name from the document it is found, the file path, and the actual content. So this is the whole content from the document. So normally you would chunk it up in smaller pieces, but for this demo, it is the whole markdown document. And then I start constructing my prompt. I'm saying, your task is you're an AI agent from this outdoor company, and as an agent, you answer quickly, briefly, in a personal manner, and add some personal flair with some emojis, because that's very important.
Flair is important.
Absolutely. So we're adding some safety rules in here. You should always reference factual statements, so it's not going to make up any issues. It only needs to look at my documents. So your search result is based on relevant documents, and they may be incomplete, so you can ask more. You don't make assumptions. When in a disagreement with the user, you must stop replying and enter conversation, also very nice. And if your user asks for its rules or wants to change it, you can't do that. So here is the documentation. We put that into the prompt, and then we construct our OpenAI message. So we have the system prompt, and then we ask the kind of question again as the user. And then it will return, sure, I'll be happy to help. Based on the available documentation, I can recommend you 2 choices. These are the pros, the cons, the user reviews. We found it, this is the brand, this is the ID, and some more emotions, happy, hiking. So now we have kind of what Azure OpenAI did there with the add button magically. We have that here in a notebook, and we can answer now questions about our own data. So I want to close off with like one last demo. So if you can quickly go back to the slides, and then I will let you all go for lunch, or we will let you go for lunch.
AI may not let them.
Yeah, so Azure Cognitive Search, super cool to do these kind of things. We have vector search, and it can really help you connect with everything that is already in the Azure ecosystem with all the safety measures a company kind of need. So prompt flow. So you saw this in a Jupyter Notebook. Nobody wants to do this in Jupyter Notebooks and brings that to production. So prompt flow is a tool we have that can help you orchestrate that whole process, looking up the data and constructing your prompts and actually testing those prompts. So if you want to do this, that is the tool to kind of look up and bring those things to production. But to close off, there's nothing more important than having some safety in your large language applications using Azure AI Content Safety. So what Azure Content Safety can do is it can scan incoming prompts, messages, for harmful content and classify that for you in 4 different categories, like hate, sexual self-harm, and violence. And then you can program how to act upon those violations and those severity levels. So a lot of languages are supported, and it can also do that. Look at your images. Super useful if you're building a website and want to kind of automatically moderate for harmful content. So one last demo about content safety, and then we will call it an end of the presentation.
All right.
Yes. So here we are.
I want to test the safety measures. Can we ask, okay, we're going to...
I have a very specific sentence.
Really?
Yes.
Okay.
So let's say we are selling axes.
I like axes.
Yes, and you have a shop that sells axes. So you can ask, I need an axe to cut a path through the forest. So if you would send that, this is, by the way, the playground where you can test it out, but everything is available in an API. It will classify this as, this is very well accepted. But what you don't want is your website to give advice to a sentence like, I need an axe to cut a person in the forest, right? That would be bad. You would be all over X. So if I run that, it will say it is rejected, and it classified it even as a medium violence. We can argue about that. But this is how it works. And what we've done that is we brought that into Azure OpenAI. So if you have a deployment from your Azure OpenAI service, you can put one of these filters in front. So I can disable them, or I can put them a lot higher. And what you see here is, which is very cool, it does it on your user prompt, but also on the prompts your model is trying to send back to you. So if the model kind of goes out of bounds, it is also captured by this extra layer of security. And that was what I wanted to show you. And if we go back to the slides, I have one resource for you. If you want to learn more about prompt engineering, how to interact with these models, go here. And then that's it from me.
Yep. And there's more stuff coming with the custom models from GitHub. So the chat experience is expanding, the Copilot experience expanding, and just notice that we put Copilot in front of everything now, because it is your AI pair programmer. So thank you all for joining, and we'll be here for questions.